Good day from Chem Help ASAP. In this video, we will learn about acylations of organometallic reagents through a functional group called a Weinreb amide. The research was performed by the group of Professor Jeff Johnson at the University of North Carolina at Chapel Hill. The work was published in the journal Organic Letters. The citation is on the following slides as well as in the video description. On the top line is a reaction of an acid chloride with a nucleophilic amine. We make a tetrahedral intermediate, lose the chlorine and a proton from the nitrogen to make an amide. This reaction moves the carbonyl group, the acyl group, from the chlorine to the nitrogen. We acylated the nitrogen and made an amide. It would be nice to acylate nucleophilic carbons just like we did the nitrogen. Now on the bottom line, let's start with an ester and react it with methyl lithium. The carbon attacks to make a tetrahedral intermediate. The alkoxy group is lost to form a ketone. Wonderful, that's our carbon acylation. Here's the problem. The ketone is a good electrophile and can also be attacked by methyl lithium. How can we stop the reaction at the ketone? The acylation product. Something called a Weinreb amide can help. On the left, we have an amide with a methoxy group on the nitrogen. This is our Weinreb amide. If we react this amide with an organometallic, let's use methyl lithium again. The carbon can attack at the amide carbonyl and make our tetrahedral intermediate. You might be tempted to kick out a leaving group to make a ketone, but that doesn't happen. The oxygen of the methoxy group and the O- form a stable complex with the metal counterion, lithium plus, in a 5-membered ring. The ketone doesn't form. At some point, water is added to the reaction. Through protonation and elimination of the nitrogen group, we get the ketone. Will methyl lithium attack again? No, because the water will have quenched the methyl lithium. The ketone only appears in the reaction once it's safe to do so. Through a Weinreb amide, one can acylate an organometallic reagent. Let's see a real example from the Johnson group. In pursuit of a complex natural product, jervine, at the bottom of the screen, the Johnson group needed to make a ketone, shown in the upper right. And there is our ketone. They used a Weinreb amide starting material, shown to the left. It's a complex molecule, but just focus on the amide with its methoxy. Reaction of this Weinreb amide with a Grignard reagent, over the arrow, formed the desired ketone in 89% yield. This transformation would have been very low yielding had they used the ester instead of the Weinreb amide. The ketone product includes many of the atoms found in the right-hand portion of the jervine product. In conclusion, Weinreb amides allow acylation of organometallic reagents, and the Johnson group used a Weinreb amide with great success to advance their synthesis of jervine. If you are interested in learning more about the work of the Johnson group, then check out the reference on this slide or in the video description. Please subscribe, like, or leave a comment. Take care.